Hi, welcome back to the Trusted Data Architect channel. I am Anil Sripada, and this is episode 3 of Project SourceTRU. In the first two episodes, we looked at the problem. Enterprise truth is not sitting neatly in one system. In this episode, we move into the platform design. We will follow one simple operational event and ask a practical question. How does raw data become a trusted answer? If you haven't watched the previous episodes yet, please do so before continuing with this. If this series is useful, please subscribe to the channel. It helps me keep building this architecture series in a structured way. A message has just arrived from the baggage system. It says loading is complete. That sounds useful, but should Project SourceTrue believe it? The message could be correct. It could also be late, duplicated, incomplete, or connected to the wrong flight. This is where architecture matters. The platform should not treat arrival as trust. It needs to decide what must happen before this event can influence the departure answer. Enterprise data does not arrive in one clean stream. Some data arrives as files, some data is requested through APIs, some arrives as events within seconds. The platform needs one architecture, but not one ingestion method. A file may need schema checks and reconciliation. An API response may need request logging and freshness checks. An event may need duplicate detection and ordering rules. The design must respect the rhythm of each source. Before transformation, preserve what arrived. Keep the original payload. Keep the source. Keep the business timestamp and the platform receipt timestamp. Keep the correlation identifiers. This is not just a storage habit, it supports replay, investigation, and audit. If a consumer later asks why the platform produced a certain answer, the answer cannot be a guess. The platform must be able to point back to the evidence. Arrival only proves that the platform received something. It does not prove that the event is safe to use. The platform checks the source identity. It checks the structure. It checks required values. It checks whether the timestamp makes sense. When an event fails, it should not disappear silently. It should move to quarantine with a clear reason. That is important for operations. It is also important for trust. People need to know whether data was accepted, rejected, or delayed. Different systems often use different words for the same business idea. One source may say complete, another may say done, a third may send a short operational code. A simple mapping can align field names, but harmonization goes further. It aligns meaning. It says in this platform, these values represent the same business state. At the same time, the platform should not erase source context. We need the common language and we need to know where the original value came from. The same flight can have several identifiers. A passenger may know the flight number. An airline system may use an operational leg identifier. An airport movement feed may use a different reference. A baggage event may contain only one of those identifiers. Before the platform composes state, it must resolve the correct flight instance. This is a hidden architecture problem. A perfectly valid event attached to the wrong flight is still a dangerous event. Events describe moments. A baggage event says something happened at a point in time. A gate event says something else happened. An aircraft movement event says something else again. But consumers usually do not want a pile of events. They want the best current view. Is the aircraft here? Is the gate ready? Is baggage loading complete? The platform must compose that current state from evidence. This responsibility should not be hidden inside a dashboard query. Trust is not one final validation step. It operates across ingestion, processing, state, and delivery. Freshness must remain visible. Lineage must remain visible. Quality status must remain visible. Ownership and access must remain visible. If trust is added only at the dashboard, it is already too late. The platform should detect loss of trust before the consumer does. The baggage event is a fact. It is evidence from a source. The current readiness state is composed from several facts. The expected departure estimate is derived intelligence. These responsibilities should not be collapsed into one opaque pipeline. When we separate them, the answer becomes easier to test. It becomes easier to explain. It also becomes easier to improve later because changing the intelligence logic does not require changing the meaning of the underlying facts. A table can store data, an API can expose data, but a data product adds a contract. Consumers need to know what the fields mean. They need to know how fresh the answer is. They need to know the quality expectations, the owner, the access rules, and the version. This contract protects consumers as the platform evolves. It also makes the platform easier to govern. Now return to the original baggage event. It starts as a message from a source. The intake layer receives it. The raw evidence store preserves it. Validation decides whether it can continue. Harmonization gives it a common meaning. Identity resolution connects it to the right flight. State composition decides how it affects the current view. The data product then exposes trusted answer to consumers. The event was not merely transported, it gained context, meaning, identity, and trust. There are three lessons from this episode. First, preserve evidence before transformation. Second, separate validation, meaning, identity, state, and intelligence. Third, carry trust into the final data product. This is the difference between a data pipeline and a trusted data platform. A pipeline moves data. A trusted platform creates an answer that people can use, question, and explain. In the next episode, we will go deeper into current state. What happens when events arrive late, arrive out of order, or are corrected after the fact? If you found this episode useful, please like the video. It tells YouTube that this kind of practical architecture content is helpful. Please also comment below. I'd like to know which part you want me to go deeper into: ingestion, validation, identity, current state, or data products. And if you know someone who is moving from data engineering into architecture, please share the episode with them. Subscribe to the Trusted Data Architect channel for the next episode of Project SourceTRU. Thank you for watching.